Thank you. So what are data structures and algorithms? This content is already in the LMS. So data structures and algorithms is basically, this is what happens from the content in the LMS. So far, you have only stored these bits of data in variables and all those kind of things. You have learned functions and all those kind of things. So, but what happens if you need to work on a complex information? What happens if you need to work on complex information? Maybe creating an algorithm or creating something, or sorting up a list. In case you have a list and you want to sort this list in ascending order, descending order, you want to get a particular item from that list, what happens? So kindly make sure that we are on mute, Japheth. Okay, so such a collection of data like a list of people or list of companies, maybe you want to sort that kind of data, maybe a number of people in an organization, the number of people or number of students. It's good to know data structures and algorithms. So we know how this information works, how we can sort this out, and everything like that. So in data structures are designed in this very purpose. For example, we can look at this. We can look at these data structures examples. So we have two different types here. We have built-in data structures, the ones that we have covered here. That is the list, writing tuples, dictionary, or sets. Then we have user-defined data structures. So these user-defined data structures, for example, is the stack, tree, queue, linked lists, graphs, and hash maps. The way they are just the name states its function. For example, for a stack, a stack is basically you put something on top of each other. So that is a stack. A tree structure is kind of data where is kind of data where you find such that data is stored in the way a tree is like. We have the root, we have the stem, then we have the branches. So data is stored in those different branches. For example, you have a list of data, and this list of data, for example, if you are using Google Sheet, we have the main Google Sheet, then we have different subsheets where you store this kind of data. Now take that as a tree structure. We have the main data, then we have the list of data stored in different worksheets. So that is an example of a tree structure. A queue, of course, is something like this. Something like this table is a queue. We have 1, 2, 3, 4, 5, 6. The same way that you join a queue. The same way that you join a queue. For example, you are queuing to get some money. You are queuing to get something. So that's how a queue is like. A graph is just the normal graph that we know. Then linked list, maybe you create a list, and then from that list you create another list inside that list, or you link this list with another list. So that's how these data structures are like. Now you can you can decide to store data in a form of a list, or a form of dictionary, or set, or tuple. That's up to you to choose, but depends with the goal that you have in mind. So also you can store data in this user defined, either in stack, queue, tree, linked list, graph, or hash maps. So these are the kind of things that you can, or how data structure works. So in general, data structures is a way of organizing and storing data. data structures is a way of organizing and storing data. You organize data and you know how to store it so that they can be accessed and worked with efficiency. For example, you know the kind of data that you are working on. You can either store it in a form of a queue, in a form of a list, in a form of a tree, stack, anything that you want to do. So this is a way of storing and organizing data so that it can be accessed and worked with efficiently. So with that said, this data, all these methods of storing this data for efficiency and accessibility, they are critical to managing and manipulating this data in various forms. So if you organize your data, you store your data in a certain way, either in a stack, queue, tree, and the rest. Now, from that, it's easy for you to manage this kind of data. So in Python, Python offers several building data types, and these ones are the building data types, and each with unique characteristics and use case. So these ones have their own unique characteristics of this data. We are going to see examples and see the difference between building, then the difference between user-defined data structures. So for example, we can start with these building data structures. But before we start with that, let's read through this information and see if there's any information that we need to understand over here. So a data structure allows you to organize and arrange data in that form that I've said for operation so that you can access, you can operate your data efficiently. So Python has built-in data structures, and these are examples of the built-in data structures. So this one, they come with Python. They are defined the same way you write a variable. The same way you write a variable, there's a way of writing variables that is built-in structure. Then also that comes with building data structures. We have defined way, or that Python programming itself has defined, and this one is the building data types. These are considered as non-primitive data types. That meaning they are classes, they are classed as objects, and we'll expose them once we start writing these examples. So after that, we have, along with the building data structures, Python allows users to create their own data structures. And creating your own data structures are these ones. These ones have no rules, but you just need to write your own data structures and then work on these data structures on your own. Define them. If this one is up to you to choose the kind of data I'm working on. Do I need to store it in a stack, tree, queue, hash maps, graph, or linked list? So this one is user defined. It's up to you to choose depending with the goal that you want to do. So let's define some keywords over here. That is mutability. Mutability refers to data inside data structures that can be modified. For example, you can either change, update, delete the data when needed. Mutability, that means something that you can alter, you can change, you can play around with, you can decide to update, delete whenever time you need to delete these ones. So what are immutable data structures? This one will not allow modification once the data has been set.
So we can't get you.
Okay. Apologies, guys. I was speaking on mute. I think I clicked the mute button by mistake. So sorry for that. So we have learned what is mutability and what is immutable data structure or immutable data. So from that, now we can look at the examples of writing these data structures. Let's start with the linked list. And if time allows, we are going to shift into this. Or we can check at one here, we check at one here, we check at one in the building data structures, we check at one here, so that we cover both, so that we have an overview of both. So we are going to start with this linked list and not linked list, but with this list and with tuple. So what is a list? In Python, they are used to store multiple data at once. You can store multiple data at once in a list, the way the list itself is defined. So suppose we need to record the age of 5 students. We need to store that data for 5 students. Instead of creating 5 separate variables, we can simply create a list. What does this mean? Instead of creating, let me just zoom my VS Code and then show with example. Is.py. So instead of writing student 1, their age, instead of creating student 1, their age is 23. This one should be one word. Student 1. Their age is 23. Then we create another one for student 2. Then also for student 3, and give them different age. Instead of doing this, creating student 1, student 2, student 3, and then giving them different age, we can store this data in a form of a list. So how can we do this? We can define a list here and call this list, we have to give it a variable name and call it students age, age, and then we give it a list. So we are going to give this student age like 23, 27, and 25. So this is a list. So with this list, instead of writing this, we can store this age in this form of a list. And that means we have defined or we have used this list. Now, for this list, how can we print out the list or the age of these students? We just write numbers. For example, the way we have said student's age, then we have given it to that age, then you print the variable name like that. So that's how you print out this page, or no, not page, but this list. So for us, we can actually print out, we can actually print students. We can print out students' age for this list. For example, I can write this code. I have printed out the entire list. But there's a problem here. Not actually a problem, but there's another way we can do it here. Suppose that we wanted to print the age of student in index 1. In counting, in programming, we start from, we name this as indexes. So this is index 0. We start counting from index 0, index 1, then index 2. So suppose that we wanted to print out the student index 1, index 2, or index in a specific index. How can we go about that? It's very simple. So we print student's age, the variable, the same way that we have done here. Then here we specify with a square bracket, because this is a list, with a square bracket, which index do we want to print? We want to print index 1, and in index 1 you start 0, 1, 2, like that. Then we can run our code, and then it has printed out the exact age for index 1. We can change that to index 0, then it will out 23. So we can run our code, and this should just a moment, let me print out index 2, 25, index 0, save. Yeah, there we go. Index it's 23. I had forgotten to save my file. So that's how you can print a list, and you can print a specific thing in a list. So by looking of things, this age for these students, assume that you had a list of around 60, 100 students that age. Now assume that you had to create all these to 60. That could be a very, very long piece of code. And then what if now you wanted to print out the age of each student? Then do this, do this, do this. That will be a tedious task. That's where data structures and algorithms come to play. So you just define a list. Then a list is defined with these square brackets. Then here you pass the age for these students. Then here you can print the entire list, or you can print the index of a specific student, age of a specific student. That's how these lists work in data structures and algorithms. So in case you have any question as we continue, feel free to ask on the chat, feel free to interrupt me, then we are going to answer any question. So now that's how a list works in data structures and algorithms. We have another example here. Here we have created a list of 3 numbers, 3 ages according to our examples. Then from there, a list can have any number of items, and they may be different types. What do we mean by different types? For example, here we know different data types. We have numbers, strings, boolean, undefined, those kind of data types. So these ones, in our case, it's using only integers, numbers. So according to this statement, we can do different data types: integer, float, string, etc. For example, here in this second example, we have defined my, you can define an empty list, it's allowed. Then we can do a list with different data types, for example here, and that will work perfectly. For example, we can alter our example, and then we say, instead of here, we can write a float, for example 30.5. We can write 30.5. This one is a float. It accepts different data type, which is a float. We can also alter this and type a string. We just separate with a comma. Then here we can say my age is 26, like that. And this accept. Once we print the output, then that means we can access this. For example, we can try to print out this data type and see if actually it works. So index 1, 2, 3, 4, 5. So this one is index 5, like that. Save. Then we run our code, and we can see student 5. Let's see what's wrong with our data type. Index 1, 2, 3, 4, 5. Let's start with index 4 and see if index 4 will work. Yeah, my age is 26. This is index 4. 0, 1, 2, 3, 4. Yeah, that was correct, index 4. And you can see For example, the one that I tried to print out outside, that was index 5. We don't have, we start counting from 0, 1, 2, 3, 4. So that means we don't have index 5. In case I tried to print out index 5, I got this list, this error message. List index is out of range because our list does not get into index 5 and beyond. So that's how you print out these different data types. You can write different data types for these things. And this one is just a different examples of pure strings. You can print out these pure strings like that. So this one is just an example of how we count these items in that list. We start in 0, 1, 2, and go in like that. So that's how we print out these lists. Now, let's look at another example or another way you can work with this list. You can slice a list. And what does that mean when you are slicing a list? In Python, it is possible to access a section of items from a list using slice operator, not just a single item. For example, you see this is just a this one is a normal list like that. But before we go to this example, let's do this example you see here. What does this -1 mean? Let's try with the example and see straight from our example, and then we start like that. Maybe we can do -4. Let's see what it does. 27. Why 27? Why 27? Anyone with an idea why it printed? Once I added negative, initially if it's positive, it's going to print out this, my age is 26. But once I added -4, it printed out 27. Why? Anyone with an idea why it printed out that 27?
Hello.
Okay, someone is yeah, go on, Job.
I think it's counting it from the back or starting backward.
Okay, then thank you. And I have another question. Yes, we can start. It's counting from, initially it counts from left to right, but with negative it starts from right to left. But as you can see, it has printed out 27. But if we start counting, maybe if we start counting, assume we start counting from 0, 1, 2, 3, it should have printed out 20, 24. But if we are printing out from right to left, why did it print out 27 and we know we start counting from 0? Why did it print out 27? Why did it print out 27 and we know we start counting from 0? It should have started from 0, 1, 2, 3, 4. It should have printed 23. But in this case, it has printed out 27. Why that? Why did it happen?
Yes.
Yes, yes,
Hello?
go on.
Since you don't have
Yes, go on.
negative 0, since you don't have
Yeah.
-0, it starts from -1.
Perfect. So that's the correct answer. So if we are starting from counting from negative, of course we don't have -0. So it will start counting from, we don't have -0. We can't have -0. It's 0. 0 is 0. We can't have -0. So this one is 1, 2, 3, and 4. If we start counting from negative, that means we don't have negative 0. So it starts counting from 1, 2, 3, 4, -4. Then it prints out these 27. So that's the correct answer, and that's how we count. So let's continue with our examples. This content is straight from the LMS, so we are not learning anything outside there, but we are going to write more examples. So now let's continue with this example here. We want to slice a list. We are going to see from example, and then we are going to understand what is slicing from the example. So we define a list with this list. Items from index 2 to index 4. So print my list 2 to that, and then it will print out specific thing. Then you can do this with the full colon, and then you do like that. We can print out things like that, things like that. So let's do this. Let's write that example. Let's write this example and understand it better. So let's just write this example and say my list, and this my list is this my list is, let me type several like that, then I can change this to, you can just type the word python, py h, we need to more Python like that. We can type the word Python. You can type anything of your choice. Python. Yeah, that's correct. Now, this is a list, just the same list as this one. Still the same list. But now we want to do this thing we are calling slicing. So in this slicing, we can print, for example, you have seen here we just printed a specific index. What if we wanted to print out not an index, but a range of items, either from index 1 to index 3, like that? What if we wanted to print out these 3 items here in our list? How can we go about that? That's where the slicing comes in. So we do print, you print my list, then into square brackets as usual. Then here you are going to specify the range. Maybe I can print out from 0 all the way spanning to 1, 2, 0, 1, 2, like that. So all the way to index 2. Then we run our code. Let me just comment this piece of code. Then we print out this range. And we can see it has only printed out the range between, let me see, like that. Let me just clear this. Clear output. Let me run again. Yeah, there we have it. So let's explain what's happening here. It has only printed out P and Y, but we specified 0 to 2. So what do we expect in our mind? In our mind, we expect to print out 0, 1, 2, 0, 1, 2. We expect all the way to print all the way to T, but it has printed all the way to Y. So anyone with an idea why it has only printed this, but in our mind, we expect it to print from 0, 1, 2. So we expect to print 3 items, but we have only printed out 2. Anyone with an idea why it has printed those 2? You can unmute your mic, you can go on. Someone is saying to print out, let me see the comments, to print less than 1. Perfect. It exclusives index 2. Perfect. So these two answers are perfect. So they are the correct answer. Someone say it does not include index 2. Perfect. So this one, it prints out index. So it doesn't count this index 2. We're just printing out something before, exactly before index 2. Yes, it will start counting from 0. It will count from this and this, but it doesn't print this index 2. That's what really happens over here. It doesn't print out this index 2 because it's this range. It excludes these 2. So it doesn't print out the T. So that's what it happens for this case. So from the answers, I can see we are together, and I think we are enjoying these data structures and algorithms. Maybe for those who have joined, right now, I've shared some notes for you, and these notes are basically these ones. These are just the examples, extra examples of these data structures. So these notes are just summary of everything here in the LMS of this week 2 content. This week 2 content is this summary, heap, sort, blah blah blah, and the rest. So this is the summary for this content in our LMS. But what we are doing today, we are just going through this. In case time allows, we are going to go through all these examples. But this one, we don't want to rush. We want to make sure that every bit that we cover, we understand these and how things work. Data structures are very essential. Someone say kindly share. Someone has shared. Thank you, Hassan. Thank you, Hassan. Hassan has shared on the chat. So you can go through that. So let's continue. And also for those who have joined, in case our Zoom account kicks us out, nowadays Zoom is misbehaving. It's kicking everyone out. In case it kicks us out, kindly just rejoin the same way that you have joined the session. Kindly rejoin in case Zoom kicks us out. So let's continue. We have printed out this range between index 0 and 2. Let's look at another example here. What if we do this? My list. So let's try with an example of now let's do this example and see full colon. Not there. Here. This full colon like this. Now, what if we print out this without specifying from index 2, maybe 2 to 5? What if we don't include the 5? Let's run our code and see the output, and then we explain from the output. So once we do this, it tells our program to do this. Print all the way from index 2, 0, 1, 2, print all the way from index 2, all the way to the last item in our list. And that's what exactly it has done. Print out from T all the way to N. So this means don't specify the range, but specify where our code or our algorithm starts. Start from index 2, then print the rest of the items from our list. What if we do the opposite? Now the 2 was here. What if we do the opposite like this 4? Let's see if our program accepts or it doesn't. Perfect, it works. That means we can print in the opposite way. It has started from Python all the way to N. N is 0, 1, 2, 3. So it doesn't include the 4 as obvious, but it has printed anything behind or before this index 4, like that, and it works perfectly. So this is how this thing works. How can you use this in real life? How can you use this in real life? For example, you are creating a platform. And of course, we have those kind of people. They have at least around 4 names. See, they have 4 names. But of course, I know people from my country. These people from my country is their names. They range from 5 characters all the way to maybe 10 characters for just writing one name. For example, you can see the name for our friend Kada here. It has several characters: 1, 2, A, B, D, 3, 4, 5, 6, 7, 8, 9. So that we know, maybe that is the longest name that we have from our list. Maybe you want to print out that only this first name from our list. How can we do that? We can do that with defining these lists. For example, you have joined Google and you just see Google, yes, you have around 10 names, but it has only printed out 2 names. How do we go about that? We take the name, the list of items from our list, and then it prints out maybe the first 2. And the first 2 is your first name and your second name. Maybe the other 2 names, they are not important for that case. You just don't print them out. So this is how it works. Maybe you have logged into a system. For example, I can show you an example here. Let me show you an example of how this thing, you can use it in real life. Maybe assume that I've logged into this system. But here, you see, my name is Evans Nyamai. But how do I print out this first character here? E. I just show E. I don't want to show any other character. That's how you go about it. With list, specify what you want to print. Is it index 1, index 2, index 3? That's how you go about it. And this one is valid. And that's how you can use this in real life. So let's continue. So let's continue. Someone is telling us to print Eric. Eric Wesonga. Let's see what your solution does here. You're telling us to print out a certain range in the opposite way. We have done the opposite. We have done the positive side of it with whole numbers. What if now we do the negatives, the same way that we have done the negatives here? So negative 4 is 0, 1, 2, 3, 4. Negative 4 should be this one here. So positive, this is 4. What if now we go negative 4? But no, it should start counting. Let's see from the example and then we judge our answer. Let's see. From index 4 all the way to negative index 1. Yeah, perfect. So it works. This is how it works. From negative 4, start from, doesn't count from negative 0. So this is 1, 2, 3, 4. That is negative 4. So negative 4 is T. Perfect. But we are going all the way to negative 1, 0, negative 1 here. So it will print out from negative 4 going forward to negative 1. This one here. And that's how it's counting. As usual, doesn't include the first index here. That is negative 1. Doesn't include, now it will print this particular range. That's how it works. So thank you for giving us that example, Eric. Thank you, Eric. And I can see you guys are really following these examples. Someone is saying they don't understand this. Where are you lost, Patricia? Where are you lost? So that we repeat, we make sure that we understand this. You don't understand the whole concept, data structures? Someone is saying, you thought it's going to print going backwards? Yeah, let me explain again. So let's print -4 without including the, let's say, -2, like that, and print -2, it prints ON, O-O-N, O-N, yeah. It's not going to be going backwards. It's going to go this positive way. This one is negative. Let's see, once we try -2. Yeah, so this is what happens here, for example. Let me just copy this and print the difference between the two and know why it's not going backwards. So here we have our two outputs, one for positive, one for negative. So if it's positive, it starts counting from left to right. Then if it counts from left to right, P all the way to from index 2. Index 2 is 0, 1, 2. Then going forward to the last index. But -2, it starts counting from right. 1, 2, -2. When you add the negative, it changes where it starts counting from. Positive, left to right. Negative, right to left. And then it starts counting from here. Then it will print out from here all the way to this one. It's not going to go negative. The reason why it does not go negative, remember this example here. This one was a positive, normal way. But this one, we have added another concept here. And this one, we are calling it slicing. This one is a concept of slicing. Because we have included, you see, we have included this full colon. We have introduced the slicing. That's how it's working. We have introduced this slicing. Now it's not going to print out negatively way or in the opposite way, NOH, like that. It's not going to print out like that. Thank you, Patricia. So what we just need, someone is telling us, Peter, we can print out from -2 to -4. Let's try. We are here to try. Let's include your example here. Print out. Let me just copy this, X, my list, then add your list brackets like that, and comment the 2 and see what it's going to print. So this one we have started from -2 to -4. Let's try and see the output. It just printed out an empty. That means we can't do that. Maybe we can do -4 and -2. We alternate, we try, and this one what? So we can't do the other example like this one here. This one is not valid. It's not going to print out anything. Okay. Actually someone is explaining here, Eric Wesonga. It's not printing out something because it's an empty, since -4 is less than -2. That means it's not going to print out anything from our list. And that's how these lists work. So let's continue and see something extra. We have understood these listings here. So this one is basically the definition or explanation of this. So let's read this note. When we slice a list, it starts index. We have defined this. It doesn't count the index that is the at the end. So let's see another example here. Add an element to a list. Add an element to a list. How can we add an element to a list? Maybe we define our list here. See this list? We have defined this our list. But how can we add an element into this list and print out that whole list? How can we add? Maybe someone is assuming we are going to add like this. Maybe someone is assuming we are going to add this like this Python 3.5. Maybe someone is thinking we are going to add like that. But we can actually do something we call append. Create a list, create a function for append. Then after appending that list or forcefully appending that list into our list, then we print out the results. So let's define this variable here and call it numbers. And then I'm going to do this. Maybe a list of numbers like this. So of course I'm going to print out numbers. Of course I'm going to do that. And I'm going to print out maybe the one in index 3. But assume now we wanted to add a 9 here like that. Assume we wanted to add a 9 here. We can use the append method like that, and then we just append this 9 to our list. So now let's do this. We use the append method to append our items into the list. We use the append keyword, this append method here. For example, now you see this number. What if I wanted to append something else? I can do numbers dot append like this. Then I can append, for example, something character that does not exist. A number is 9 like that. Now we can print out our output and see the output. Let me comment this. So now we can print out this and see if 9 has been added into our list. Let's print out. Then there we go. We have 9 in our list. We have 9 in our list. It has been appended over here. But as you can see, it has been appended as the last index. So that's how you append these numbers into, or you append an item in our list or in any list you append. Once you append, by default, it will append this character you have appended here, or this item you have appended here. It will append it as the index. You can use this in real life situation. So let's see another example here. Using extend, using this extend method over here. So you can append another list inside another list with this extend. So this one I'll leave it for you to go through. I'll leave this for you to go through this list. So just go through this list. This example here is the one that we just covered here, printing an index. Printing a negative index, we have already covered that. We can actually count the number of items in a list. Not list, actually this one is, yeah, this one is no longer a list, it's a tuple. Let's see where tuples begin. Yeah, this tuple here. Now, we have covered these lists. And lists, the difference between list and tuple, this one they use list, they use square brackets. Tuple, they use curly braces, not curly braces, but the brackets. They use brackets for tuple. That's the difference between the two. So let's go to tuple. Tuple, like that, dot py. Tuple dot py. So let me connect my machine to my charger. It's going off. Then we continue. Give me a second. Okay, let's continue. So let's check at tuples and how tuple work. Let's see how these tuple work. Then after the tuple, we are going now to go to this. We try one. We call them, what do we call them? We call them non-primitive algorithms. So let's create this tuple. So what are tuple? Or what is a tuple? A tuple is similar to a list. The difference between the tuple and the list is that the two is that we cannot change the element of a tuple once it has been assigned to anywhere. We cannot change an element of a tuple. What do we mean by element? We are going to see the examples. How to create a tuple? So a tuple is created by placing all item element inside the parentheses, these brackets, separated by a comma, just like a list. The parentheses are optional. However, it is a good practice to use them. The parentheses are optional, but it's a good practice to use them. What do we say by the parentheses are optional? Maybe we can say my tuple, and this tuple, can ignore the spelling, This tuple can be a tuple of items 2, 3, 5, 7, 9, like that. This is a tuple, and we can print out my tuple like that, and it will print out my tuple like that. You see, this is a tuple. By default, Python has understood this is a tuple, and you can see it has printed out in the parentheses like that. But we mean the parentheses are optional because we can either decide to write it as open, or we can include this into this tuple. Why? It's a good practice because at some point I can be writing my code, and then by any mistake I can start editing my tuple, and then I find, wow, it's printing a different result. I don't know why it's printing out a different result, because maybe by mistake I typed this and I don't know where this error is originating from. But if you enclose something like this, it's easy for you to just identify where the problem is from your human eye without depending on the interpreters and the compilers. So it's a good practice to write this. So this is how tuple looks like. So we can actually print out an item from our tuple. This one, we can print out an item from our tuple. For example, we can print out the one in index 2 like that. We can try and see this one object is not callable. So let's see how we print out these items from our tuple. Before I correct this mistake, anyone with an idea how we print out this tuple? As you can see, I've gotten an error. Tuple is object is not callable. Anyone who can see where the error or where I have typed something wrong before I correct it? Anyone who can see? You can type on the chat.
Hello.
Go on. Yeah, go on.
Use curly braces instead of the parentheses.
Curly braces looks like this. This one?
Oh, no, the other one.
The square brackets.
Yeah, the square brackets, yeah.
Yeah. So instead of using, you see here, where is it? This one here. Instead of using this brackets, I use square brackets. So now it's saying tuple object is not callable. How do you call a function? You write a function, then you call, maybe assume that is a function. Now you call that function with these parentheses, but it's saying this one is not callable. So this one is for calling this object, this tuple object. It's assuming it's a tuple and it's not callable. So that one brackets is for calling this function. So instead instead we use square brackets, then we print out index 2. Let's see. Let's run our code, and there we go. Index 2, 0, 1, 2. The normal way we have printed out our list. That's how you print out this tuple. So that's it for the tuple. So also for the tuple, you can do the negatives. You can do the -2, and the -2 is printing out 9. 1, -1, -2, -2 is 9. So let's see if it's going to print out the same way that we have done -4. The same way, we are just assuming, we are just trying things out. This one, it has not printed out. What if we do the opposite? 4 and 2, try out. There we go. We can do this slicing still for our tuple. The same way, the same thing we have done for our list, it can be applied here in our tuple. -4, -1, -2, -3, -4, 5, and this one here. So from there, now we can continue to the next example. So this one, you can count the number of items in that list, not list, but in that tuple. You can count the index of maybe a specific character. For example, you can count the this one. Also, you can count the index. You can print out the index or the position of that specific character, maybe like L and the rest. So that's it for lists and tuple. From our roadmap, what have we covered? We have covered lists and arrays. Maybe arrays we can transform, we can cover that later. So with that said, we said we have two different examples. We are going to jungle between the two. Between what and what? Between built-in data structures, we have covered list and tuple. Now, maybe you can try one here. This one might be complex. Maybe you can try one, stack, queue, tree, linked list, graph, or hash map. We can try one from this other side. So let's try one from this other side. So let's see from our notes which one looks easier for us to maybe understand with. This one is a linked list. You see this list we have written here? You can write a linked list. Let's see from our examples which one looks simple for us to understand. We start with it, then we advance to the other ones. So this one, we are not going to follow any particular order. So we are going to, let's try with this stack. Let's try with the stack. Stack, exactly. Stack starts here. So let's try with stack and see how stack works like, or how stack works like. So for this stack, we have said if you have something in form of a stack, what do you say? You put something on top of each other. What if I have maybe a stack of 15 books and I just want to pull one of the books, and in the books it's in the middle. Maybe it's the third book from bottom. How can we do that? We can pop that particular thing. It's a stack, we can pop. What if I wanted to remove a book from the fifth from top? I can do that. I can print out that. I can remove that from our stack. What if I wanted to just count? I can do that from stack. What if I wanted to include another book, maybe in position 7, any random position? I can actually do that from a stack. Maybe we have a stack of books, one placed on top of each other, just like that. Then we do that. So in stack, we call it a linear data structure following the LIFO example or the LIFO principle. What is the meaning of this LIFO? Anyone with an idea what is the meaning of this keyword LIFO? We have LIFO and we have the other one is, let me see, we have LIFO. We have LIFO and we have FIFO. FIFO. Anyone with any idea of what this means? Yeah, thank you, Hassan. Last in, first out. Now assume you are entering a hall, right? Then in this hall, not the hall that has been dug, I mean the conference room. Now once we join or once we enter and we start planning our, once you get to the, go and sit in the front seats in a certain order, start from the edge all the way like that, all the way from like that. And if the hall is full or the conference room is full, all the way to the back. Now assume the door is at the back. We started joining from the back, and then of course that's how most of these like start sitting from like that. The LIFO means if we want us to come out in a good order, how do we do that? The last person in the back starts coming out all the way to the last person in the front row. So that's the principle. The first person who joined the hall or entered the hall is the one who is going to come out last. Because it's the front row, we can't just interrupt or push through the last person. So the last person comes out first all the way to that. That means last in, first out. The last person who entered is the first person to leave. So that's the basic principle for this. So let's write this example now. For this, then from that, we are going to do recursion. Recursion is very important. Is one of the algorithms that you'll be asked in an interview. Then let's do stack. From this stack, we have said it's a linear data structure. Linear from keyword line. So from here, it has its own characteristics or operations. The first one is the operation. So push, add, we have the pop is just like remove. We have the pick is view top element. From this, just keywords. Push is just adding an item in our stack. Pop is removing an item from our stack. Then pick is viewing top elements. So let's write this. Let's write this stack. We have stack dot py. So for stack.py, we do let's write a stack. A stack is always an empty stack. This is an hole that is empty. Our shelf is empty. Now we can do stack dot append. Stack dot append like this. Wait for this to go disappear. Yeah, we can do stack dot append like this. Now you can append something into this stack. Then after that, you can print our stack like this. Let's print out before we add any item in our stack. So it's saying list.append takes exactly one argument. 0 is given. We have created a list here, but we have not appended anything here. So we need to add that so that we do away with this error. Let me clear this console, then run. Then we have 3 in our list here. So we can append something else. We can append as many times as we want. We can append something like 4. We can append 5. We can append 6 in our list, in our stack. Then run, as you can see, we have this. So by default, this stack data structure is, we have said according to our definition. Where is it? Where is our definition here? These maybe stack tree, they are user defined data structures. They are not inbuilt. There's no a specific way to use them. It's for you to define how you want to use them. We have no rules. We have no rules. We can add and append a very good list here, something like that. It's allowed. It's allowed. So this one is user defined. Doesn't have those complex, those specific rules. You have to use it in this way. No. So you can do that. Now let's try another example here. Let's try another example here. Let's try another example here and maybe try to print out something in stack index 0, 1, 2. Let's say we are just trying things out to see if these things work perfectly. It works perfect. That means we can append in our list, but we decide to print our stack and we decide to print it where? The only one in index 2, 0, 1, 2. Perfect. It works out. So that's how this big boy works. So with that, now we can continue with our example over here and see how someone is asking what is the difference between the list and the stack, because they look the same. Because they look the same. What is the difference? So someone has typed, Immaculate has typed, a list can store items in any order. A list can store items in any order and allows various operations, while a stack only lets you to add and remove items from the top following the last in, first out LIFO rule. So we go back, it routes back to the rules, the LIFO principle. Last in, first out. The last thing that you add in your list is the first thing to come out. So it follows the rule. So in lists, normal list, you can do anything. You can remove anything you feel like removing. So we can remove anything we feel like removing here in our list. So let's now do the stack operations. We do stack.pop. Let's see. If we do stack.pop, stack.pop, it looks like that. Yeah, it looks like that. If we do this and run our code, we can see it was 6. The last thing first out. What if we change this to here? Try out things. It prints out 3. Someone might be asking, last in, first out. But in my case, I do stack dot append. Dot append what? Dot append 12. In layman's language or in layman's understanding, what was the last thing that I added into our list? This one, in layman's terms. But in programming, what is the last thing that I added into our stack or in our list? It was 3. Why? They started counting from 0, 1, 2, 3, 4. Let's run this code and see it's 3. So this is the last thing in our list. So that's the principle. Last in is the last thing in our list, the last item in our list, or the last thing in our list, or the last element in our list, if you call it so. So that's how it works. So you can pop this like this. Maybe you can try to use another method here, that is remove. We can pop, we can remove, and see how this tells us traceback error. Let's remove text exactly one argument at a given. So this error guides us what is the next step. What do you want to remove? I want to remove 1, 2, 3. Let me remove the one in index 3 and see. We have none. Let me do 12, none. So someone can explain to me what's going on here, or can give us an example of this remove method. Someone can give us an example. Someone can give us an example. You can Google, give us an example. You want to use your example, you can remove, you can pick from top. Someone can give us an example. You can Google. You can Google and paste the example over here. You can also GPT and give us the example over here. Someone give us an example. Do stack start in index 0? Yeah, this starts from index 0. This one, this starts from index 0, like that. So this one, you see this one is just similar to type in 4, 5, 6, blah blah blah. Just similar to doing this, but the difference comes with these methods here, or these operations. That is like this. We are waiting for one to give us an example of how to use the remove an item from this stack. Someone is asking, at which instance do we use stack? At which instance do we use stack? Anyone with an idea? At which instance do we use stack? Thank you, Karin. Okay, let's try with your example, Kevin. Kevin has given us an example here. Let me do this with stack from our friend, stack from our friend Kelvin, like that. Then I use stack dot remove from the example that we have been given by Kelvin. Let's name it like stack Kelvin. what's going on here. Star Kevin, don't remove. Let's see. Maybe it's the variable name typing error. Yeah, it was just a typing error. So let me comment this piece of code, then we try it out. Nothing shows here, so don't think this. What? Oh, now let me print out Star Kevin like that. Let me remove C. See what we get. Perfect. So yeah, we can remove an element from our stack. How can we remove that? Assume now we have this stack here, and we have a list of things here, elements, and you want to remove a specific thing. And in our case, we want to remove this character C here. Now we use Kevin.stack, then remove C. Then we can print out the output. Once we print out the output, you can see we have A, B, B without the C. But I've seen another something here. What if we do B, save, because we have two B's? What does it do? A, C, B. A, C, B. So does it mean it has not removed the two B's? Does it mean, why does it not remove the two B's? Why does it not remove the two B's? Why does it not remove the, does the stack use the stack as the variable name? Not really. We are just defining these variables according to the thing that we are working on here, so that we refer. It does not use the keyword stack when defining this variable. We are just doing this in case I share this code for easy reference. So these variable names, they are open. You can use Kelvin. It will still work out. It will still work out this variable name. It does not use the stack keyword like this. Doesn't. So this one is just an example. It's a variable. You can give it a variable name. It will still work out. So this one is just for reference. How does the compiler differentiate stack and the list? It differentiates between stack and list because of the method that you might have used here. See this method? This method is the one that differentiates, the compiler differentiates itself between stack and list, depending with this method that you have used here. It's the one that will know, this is a list, this is a stack. So because we have around 10 minutes, 15 minutes, let me see if we can explain this in 15 minutes. What this sorting algorithm, example of this recursion. Even if you don't write the example, you just can see how this thing works. The recursion. What is recursion? A method where the solution to a problem depends on the solution to a smaller instance of the same problem. Characteristics. Base case to end recursion, example calculating factorial. Maybe, no, we can ignore this for now. Maybe we cover it in the next session. So I want us to, maybe because we have not covered the rest, I want us just to quickly explain what the rest are doing, and then we call it a day. Just explain what the rest are doing for you to have an idea. Then we call it a day. This we have already covered arrays. These are lists. The lists that are, we have just written them here, over here, these lists. We have just written these examples of these lists over here. So that one we have already covered. Maybe explain the rest. Okay. Someone is sorry. I had touched this and then I left it hanging. How do you remove the second B? How do you remove the second B? Where is it? Where is it stuck? Yeah. So this is what is happening here. So we have A, B, C, B. Normally, how do we count? We count from left to right because it's positive. This is still what happens here. Yes, we know we count from left to right. But there's another thing that we forgot to mention. Because we have specified B as this B, that means it will read through our list from left to right. Once it gets to B, it removes the B, then prints out, then it returns the variable, or it returns our list. That means the program will only run until where you find B. It will run until where you find only B. Then if it finds B, the program terminates. It won't run past this. So it will just go into our room and identify, where do I see B, the first B, like that. Remove the first B, ignore the rest. So that's what is happening here. Read through left to right. If I find B, I terminate my program, then print out the rest. I don't need to know what the rest are or what else is in the list. So that's why it didn't remove the second B. Read from left to right. If I find B, remove the B, terminate my program there, then print out the output. That's why it only removed the first B. Read through from left to right again. Then, where do I find B? This is the first B. My program terminates. My program ends there. I don't have to think. I don't have to do anything else. I'm tired. Let me terminate my program there. Ignore the rest. That's why it has not removed this second B. So, as you have identified here, what if I wanted to remove all the B's? You see, if I use this method, it only removed one. From the look of things, from just the look of things, this is just one good disadvantage of it's one disadvantage of using this stack. Everything has an advantage, everything has its own disadvantage. That's how this one is doing. We have been given another example by Kelvin here. Let's try to use this other example from our friend Kevin. Why am I getting this error? Let me just copy this. I think it's typing error. 1 comma. What is the difference between these two? This Kelvin and this other Kelvin, man. This thing is weird, man. So let's try this. Let me comment this and run our code and see the output. This tag removes text.
Hello, Maria, can you hear me?
Yeah, I
Okay, how are
can
you
do.
this morning?
I'm fine, and you?
No, it's okay. We're working on it on this side. I do need to, now that I have you on the line, I guess, let me just see what was the update on this. Copy of the database, zip it, and then send it to me via. Okay, can I have your any days, please?
Sorry?
200 database, database, connecting. Please accept for me. Please accept. Oh, I'm just waiting for the images to come through then. It's going to take some time because we need to understand where the error is coming from. I know it is a bit frustrating for you, considering that you need to get.
Sorry, I think
I am.
it
I
was
just need to see where this is.
kindly mute your microphone. Okay, I think it was a problem. So where were we? Let me check from the chat. Sorry, Mohammed. Sorry. You guy, we are in class. Freezy, we're in class. We are in class, man. You can just wait, we wind up. I can see you. We can see you. We can hear you. Madambo, we can hear you. We can see you. We can see your comment, man. Okay, where are we? We are about to wind up. We are just going through this and see the general definitions. And then we wind up. So the next thing, it was linked lists. A linked list is a collection of nodes where each node contains data and reference to the next node. From that definition, it's just each node. A node is like an end. You tie, for example, you tie a string into different nodes. So we have a node, we have a next node, we have a node, we have a node. Not like that. For example, you tie a rope into nodes, not like that. For example, just take that as a basic example of these words nodes. So you have to move. One node is connected to the other node connects to the other node. So for you to move into the next node, you have to pass through this node. For example, for you to get into in touch with the president, you have to pass through this particular barrier, then move to secretary, move to all those kind of chains. No, you have to pass through one, go to the next, like that, all the way to the last node, and the next node or the last node can be the contact person you want to contact. That is the, for example, a president. Assume that like that. Just assume it like that. We are going to go deeper into that. Heap stack, we have done the stack. Heap, a definition is a special tree-based data structure that satisfies the heap property. So the heap property can have a maximum heap where the parent node is greater than the child node. So we are going to get deeper into that and to see how we work around this. I've already covered the stack. Then we have the binary search. The binary search is an efficient algorithm for finding an item from a sorted list of items. And this one uses the time complexity. This one we are going to go into it. Then we have its characteristics. It's required a sorted array. What do we mean by a sorted array? Something that is sorted. For example, is sorted in ascending order or descending order. For example, 1, 3, 5, 6, 7, 7, 9, and the rest. This one is a sorted list. You see, this one is a sorted list. So for it to be efficient, effective, you have to sort your list. Then from that list, you can search an item from this sorted list. Then we have recursion. Recursion is basically a method where the solutions to problem depends on the solution to a smaller instance of the same problem. A very complex statement here. Characteristics, base case to end recursion. See example, we are going to, in case we are seeing we are rushing, no, we are going to get back into this probably in the next session. That is probably next week, or if in case the next session that is in 2, in case time allows, we get into this. We have the sorting algorithm. This one, we have bubble sort. In sorting algorithms, we have several. We have the bubble sort. This one is a simple comparison between sorting algorithms. So for now, let's just have that information in mind. We are going to get into this. This one is just an overview of what we are going to be doing. So in overview or in conclusion, an arrays are great for indexed access but have fixed sizes. Arrays, they have fixed sizes. Maybe index all the way to 10, that is fixed. Linked lists offer dynamic sizing for easy insertion. What about heap and stack? This is an overview or a summary of everything over there. So heap and stack provides a different methods of managing data based on a specific use case. Depends with the use case in case you want to do this. Binary search is an efficient for finding elements in assorted arrays. Maybe you have blocks, and these blocks you need to search them, but they have already been ordered by timestamp or by the time that they were posted. They have already been sorted in that order, so you can easily find something like that. Recursion allows solving problems by breaking them into smaller sub-problems. So this recursion, you break a bigger problem into smaller problems and then you solve those sub-problems. Sorting algorithms like the bubble sorts help in arranging data through more efficient algorithms that exist. So that's it for today. We are going, oh yeah. Why do I keep forgetting? We are looking the difference between something and something. Yes, Kada, we are going to get into that. Then we have some quick fire questions. We are going to play some trivia here. So be ready. We are going to play some trivia. You remember the one that we played with Chance for answering some quick fire questions? Yeah, we are going to do it. So let me explain this first. We got a problem here. Then we got interrupted. So Kevin gave us the solution. Then he told us to try this out, the remove. And we added 1. So it will go and remove the first B. Let's see if that works. We tried to run our code and it told us in this remove method takes exactly 1 argument. We gave it 2. That means this one doesn't work. We can't pass 2 arguments over here. What if we pass 2 strings? What if we pass 2 strings? Still, we gave it 2. It only requires 1. That means that one does not work. So this one, from the error message, it gives us clear direction. It takes exactly one argument. So you guys, are you ready for the quick trivia? You ready for the quick trivia? You ready for this quick trivia? You ready for this? Someone say -1 should remove it. Let's see. Is that true? -1? -1, comma this? No way. This one still takes 1. Okay. So let's do the quick trivia. You are getting different solutions here. Getting different solutions over here. Can you do uniform array? X is not in list. God damn it. Okay, let's play this some trivia here. Yeah, the evening session will be the same. The evening session will still be the same. I've been given different solutions here. Doubt this works. Yeah, doesn't work, man. So let's play this quick trivia here. Where slideshow. Boom. There we go. I hope you guys are ready. I'm going to read through these questions, around 5 or 10 of them. Then we find out. So let me jangle between my two screens like this. The first question, data structures and algorithms. The first question, what is the key characteristics of an array? What are the key characteristics of an array? An array has dynamic size, fixed size, slow access by index, contains node with 3 references. A, B, C, D. Which one is the correct answer? What is the key characteristics of an array? Key characteristics of an array. Key characteristics of an array. A, B, A, someone say B, B, A.
C.
Someone is saying C. What does C has to offer? C. C tells us is slow access by index. Key characteristic of an array: dynamic size, fixed size, allows access. So we are going to get the answer straight from these slides. Someone saying D. So let's see. An array. Arrays are great for indexed access, but are fixed sizes. So the correct answer was B. Fixed arrays are fixed sizes. The next question Give it a moment for it to pass. Quiz number 2. Which of the following data structures follows the last in, first out principle? Which data structure follows the last in, first out principle? Array, stack, linked list, and heap. A, B, C, D. Which of the following data structures follows the last in, first out principle? Last in, first out. This one, no one should miss this. No one should actually miss this one. No one should miss this one. A, B, C, D. B, 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 stack, B, 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 B. Wow, this is awesome. And actually, we just covered, we just randomly covered this. We just randomly covered this stack. Randomly, and everyone seems that they understood the principle. Everyone really understood the principle. I'm trying to find out where the principle is. This one, it follows the LIFO, last in, first out principle. So that one was correct. Ogoma, congratulations everyone for getting that. So the next question is, where are my slides? In a linked list, what does each node contain? In a linked list, I just defined this with the example of a president. In a linked list, what does each node contain? In a linked list, only data, data and reference to the next node, data and references to the previous node, only reference to the next node. Maybe you see the example that I've said for the president. I'm here, I'm a nobody. I need to meet the president. What do? I go to my my member of parliament. And my member of parliament, what does my member of parliament do? My member of parliament links me to maybe the governor. Maybe the governor links me to the secretary or the personal assistant. And the personal assistant links me to the president. What does this linked list not contain? A, B, C, D. Let me see the correct answer. Who understood the example? Everyone is saying B? B, exactly. Someone, I can see everyone understood that. Good example of mine. So that means if I contact my MP contacts my governor of course connects me to the next. It doesn't connect me to the previous node, that is MP. No, that doesn't work. Connects me to the next. Question number 4. Which of the following operations is not associated with stack? We just have at stack. Which one is not associated with stack? We have already covered this: push, pop, pick, shuffle. What was not in our list? That's the basic example. What was not in our list? What of the following operations is not associated in a stack? Is it A? Is it B? Is it C? Is it D? Is it shuffle? Is it pick? Is it pop? Is it push? Everyone is saying D, 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 D. Wow, congratulations. Everyone was really attentive in that session. It's a very awesome session. So let's go to stack. Still, each one operation is not associated. We have push, pop, pick. So by default, we don't have the shuffle. The last question. We can skip this because we have not covered. You can wait. Maybe on your side it's loading. You can just wait. No. Let's see the next question. If we have covered, we see. Let's see the next question. You have already covered this. This one is a repetition. Question number 10. Let's see. The perfect question here. So number 10. Which algorithm is the most efficient for finding an item in a sorted array? An array that has been sorted. I gave the example of a blog where you have to sort with timestamps or the day it was posted, videos, the rest. So which algorithm is the most efficient for finding item in a sorted array? Is it linear? Is it binary search? Is it bubble sort? Is it stack? For a sorted array or for a sorted thing, anything that has been sorted, which algorithm is the best for that? Is it linear search? Is it binary search? Is it bubble sort? Is it stack? Is it A? Is it B, binary? Is it C, bubble sort? Is it search? That is stack search. Which is the best algorithm for finding items in a sorted array? Let's see the answers. Is it A? Everyone is saying A. A is linear search, binary search. This one is really confusing us. D, A, B, D, A, B, B, binary search, A. Let's see the correct answer from these slides. I just shared it here. So this one we just did it here. The answer is binary search, an efficient algorithm for finding an item from a sorted list of items. Efficient algorithm for finding an item from a sorted list or a sorted array. So the correct answer is this is the correct answer. The correct answer is the correct answer is binary search. So binary search is the correct answer for this question. So basically that's it for today. We are running out of time. So thank you guys for joining. Feel free to ask any questions in the next session. I'll share my contact details. So I'll stop.